I better actually record. There. Okay. So the practice test, we'll keep going through the practice test, but the sheet I forgot to bring last day is just the breakdown. So I'll just go through the breakdown of the final exam, just the types of questions, and then we'll keep going through the solutions. And so, what else now I'm like panicking because it's our last time together. So I'm like, what else did I want to tell you guys? Let's talk about office hours, or more like when I'll be at the school so you can ask questions. Oops, I was supposed to say all day, which is kind of 9 to 5-ish. Usually I'm here later and earlier, so, but kind of that block. Thursday, Friday, and Saturday doesn't really help you guys. Your exam's not till Thursday, right? But in case you're around and you have questions, I'm here. I have an exam on Monday, so not available on Monday. Just because I know it'll be crazy. But available Tuesday, and then not available, unfortunately, on Wednesday because we have a department meeting, but available Thursday, and our exams in the evening. So I'll be here all day on Thursday, which is when I anticipate most of you will have questions for me. So, or text me anytime. My number is 250-864-8386. And I think most of you guys were here last day, right? But there's those review sessions being put on by the Learning Center, free tutoring essentially. There's different sections, so you can sign up for those. Or even if you just want to take a picture in case you decide to go, that's fine too. You don't have to have signed up to go. But that's up here. And I also have 4 copies of test 3, just blank test 3s, if anyone wants a blank copy of test 3 for practice. Okay. Last day, guys. Yeah. So let's talk about the final exam format, which I meant to do last day, but that video is not working anyways, so maybe this is fine. Question 1 is going to be just 20 short answer questions. And you've seen short answer questions for test 1, test 2, test 3, so you have a pretty good idea of what to expect for those, right? Same thing, if it's one of those that can be done using your calculator, I'll just give you the strip of N, interest per year, present value, and you can just fill those in for part marks in case you're running short on time. And then we'll head into the long answer questions. So question 2, we talked about, or we did last day, is a merchandising question. 3 is a CVP analysis question, which is one of those profit functions. So profit function question. 4, we also did last day, was a simple interest problem. The one we did, right, you had to use your calculator to figure out the days between dates for the time. But besides that, it's kind of easy now that you've done annuities and these harder ones, right? And then question 5 was a compound interest problem. Compound interest, where you're solving for unknown payment amounts. And then the last one that we did last day was the compound interest problem. That you have to solve by hand, right? So you can't use your calculator. You can use your calculator functions to check your work. That's fine, right? But for marks, you have to show all your handwritten work. Here's where we're starting today. Is 7 onwards. We're going to have to do an annuity question by hand. Annuity by hand. Or here. Solve by hand. Question 8 is going to be one of those 3-phase problems, right? Just like you saw in test 3, where, okay, so we're making payments, and then we let it sit there for some amount of time, and then we get payments, right? So I'm calling that a 3-phase problem. A 3-phase problem. Essentially, it's an annuity going to compound interest, going to an annuity. This one, you're allowed to use your calculator. In fact, I'm going to encourage you to use your calculator functions, right? Because it's going to be a lot easier. Question 9 is going to be a 2-phase problem, just like on test 3 again, right? Where we have, okay, so we made some deposit, right? And then we let it sit there, and then we get payments, right? And so it's a deferred annuity. So it's a 2-phase problem. And it's a deferred annuity. And then the last question is a mortgage question, just like on test 3. So essentially, question 2 and 3 are from test 1. 4, 5, and 6 are from test number 2. 7, 8, 9, and 10 are from test number 3. And now I'll try to sell you guys on my blank test 3s that I've got available here that are probably just going to end up in the recycling if no one wants them. So test 3, it's a big one. Okay. So nothing to it but to do it, right, guys? Any questions about that? So the total here is going to be 110 marks. So total is 110 marks. Each of these long answers are 10 marks each, and the short answers are 20 marks, I should say. not really 20 short answers. Some of them are worth 2 marks. No questions? Just do it. You got it. So we finished on number 20. So now we're going to do 21. And the numbering's different because all the short answers got their own number, but that's okay. So Herbert decides to invest $1,000 at the beginning of each month to his RRSP. If money earns a rate of return of 4.5% compounded annually, what amounts should Herbert expect to have in his RRSP after 10 years? Do all calculations without using the time value money functions on your calculator. So we have to do this one by hand, just like I told you in that list. Right? So we have to do it by hand. So first thing we're going to do is we're going to make our little timeline here. We'll start it today, and up above I'll just put 10 years, but we're making payments each month, right? So we first have to figure out, okay, how many months in 10 years? It's going to be 120 months. You can just use M if you want. And then this is our first annuity on this practice test, so we have to make sure our timeline looks good. We're going to have 3 ticks at the front, 2 ticks at the back. So today, and then 1 month, and then 2 months, and then 120 months and 119 months. He's investing $1,000 at the beginning of each month. So to show that it's at the beginning, right, our first payment is today, so 1,000, and then our last payment is going to be at the 119 mark. So we shift all our payments over to the front of the section. And then 1,000 in between. Oops. So we want to know what amount should Herbert expect to have in his RRSP after 10 years? And so what we're finding, right, is the future value. And because these payments are all being made at the beginning, it's the future value due. Future value due. And that's the one we want to find. So we'll make some notes here, right? We've got our compoundings per year. Is 1 compounded annually. We're making payments per year of 12, right? Monthly payments, and we're at the beginning. I1, right? Because the payments per year and the compoundings per year aren't the same, so we have to find I2, which means we first have to find I1. And so compoundings per year is our F1, and payments per year is our F2. Our I1 is 0.045 divided by 1. Oops. Which I think we can all agree, 0.045. So I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.045 to the power of 1 over 12 minus 1. 1.045 to the power of 1 divided by 12 minus 1. I get 0.00367489. I'll make a note that I'm storing this in 1. On your formula sheet, your future value due is PMT times big bracket 1 plus I to the power of n minus 1 over I. And then to adjust for them at being at the beginning, 1 plus I. Our payment amount is 1,000 times, and then 1 plus 0.003674809 to the power of n. N is the number of payments, right, which is going to be 120 minus 1 over 0.003674809. Then here, because I'm running out of space, I'll do 1 plus, oops, 1 plus recall 1, cheating. Which, if you've told me that you're storing that number in 1, if you wanted to replace the 0.0036 whatever with just recall 1, that's fine by me. As long as you've told me where you've stored it. Okay. Start inside the little brackets and then work our way out. So 1 plus recall 1 to the power of 120 minus 1 divided by recall 1. I'll just keep going, times 1 plus recall 1 is 1,000 times 151.0286435. So times 1,000, 151,028.6435. So the future value due in terms of money is $151,028.64. So it is an annuity problem that you have to do by hand, but it's not really something crazy, right? It's just going to be probably one calculation. And so it's not a deferred annuity. It's not a multi-phase annuity, just one. Any questions about that one? Okay. All right. Oh. Draw. So next up on our list is the three-phase annuity, which I would argue is the hardest question on the test. You've seen one on test 3, you know it's kind of a biggie, right? But as long as you know how to use your calculator, it's a little bit better. There is a typo on here I see that I didn't fix before changing it. The last one should say 23 years. I think I was just trying to make switcheroos. So you've decided to invest in your RSP over the next 23 years. You intend to make bi-weekly contributions over this time period, with the first one beginning today. When you retire in 30 years, you would like to receive $1,500 month-end contributions for the next 25 years. If your investments earn a rate of 8.25% compounded quarterly, what bi-weekly investments should you make over the next 23 years? So same kind of setup, right? We're making payments, letting them sit for a bit, and then getting payments. So our timeline, again, is going to get a little crowded, right? Because we've got these 3 parts. So I'll start today. And then we're going to make contributions for 23 years. And then I'm going to retire in 30 years. So just jotting down the time points up above, right? Because down below near the ticks, I want to have my number of compoundings or the number of payments. So 30 years, and then for 25 years puts me at 55 years from today. All right, so here, this distance is 25 years. This distance is 7 years. So let's map this out. So we've got, okay, biweekly contributions for 23 years. So in 23 times 26, we've got 598 BW biweekly. So the one before that would be 597 biweekly, 1 biweekly, 2 biweeklies, ... And the first one's beginning today. So we're going to make a payment that we're going to have to solve for, right? Our end goal, again, is going to be to solve for this payment amount. So PMT, PMT, PMT. And then the last one is at the 597 mark. No worries. Okay. These are all going to funnel into some future value due. And then the next part, so when you retire in 30 years, you want to receive $1,500 month end contributions for the next 25 years. So for 25 years, monthly payments gets you 300 payments. So 299 months. I'll put that starting mark at 0 months, 1 month, 2 months, ... So I want month end contributions of 1,500, 1,500, 1,500, 1,500. These are all going to be worth some present value, just ordinary present value, right? Because the payments are at the end of each month. In terms of the order that I'm going to calculate these in, right? That's the first one that I'm going to calculate. I'm going to calculate that present value because it has all the information that we need to find it, right? And so I'll denote that by a subscript 1, which is going to be the same as, there, got stuck, as the future value, right, of this future value due, which turns into some present value, right? And so what we've got is this 3-phase problem, right? So we figure out the present value of those payments that we want. That turns into a present value, which is going to be the future value of the future value due once it's sat there for some time, right? For 7 years. Okay. So this becomes future value 2, which gets pulled back to be some present value 3, which is going to be equal to that future value due, which we'll denote by a 4. So we just snake through this way, and then we'll be able to calculate the PMTs. Okay. I'm going to use my calculator for all of these, right? And so what I find is the easiest way to figure out everything that's going on here is just listing the calculator inputs all below here, right? So each phase is going to have calculator inputs. And so we've got N interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. And we're going to make that list for each of these parts. And interest per year, present value, PMT. And then we'll fill it in. Future value, payments per year, compoundings per year, and beginning or end. And finally, N, interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. Of course, you're welcome to do these by hand, but it would take a long time. So the only thing that's missing here is the N for just the compound interest section, right? And remember, for compound interest, there are no payments. And so N is just the number of compoundings, right? And so for 7 years, the interest for all of these, which is kind of nice that it doesn't change, right, is 8.25% compounded quarterly. And so N here is going to be time times the frequency, which is 7 times 4, which, yeah, 28. Okay. So now let's just fill in the parts of the calculator that we already know, and then we'll see what we need. So N for, and I'm starting over here, right, because that's the first calculation that we're going to do, find the present value. So I'll start on the right-hand side here. N for this one is 300. The interest per year we decided was 8.25 for all the phases here. So that's nice, which means the compoundings per year are the same for all of these as well. And so it's 8.25% compounded quarterly. So the compoundings per year is going to be 4, 4, and 4. What's some other low-hanging fruit? We can do the payments per year. I'll start on the right just because that's where we're starting. We got monthly payments, so 12 payments per year. And then whenever we're doing just straight compound interest on our calculator, we don't have any payments, right? And so we just force the payments per year to be the same as the compoundings per year, right? And so we say, okay, well, this has to be 4. And I already know that there's no payments for that little section, right? So I can just put 0 there. And then for the first part, I guess, bi-weekly payments, so 26. Can jump around here. Let's fill in the ends because we started there, so 300. And then we figured out we have 28 compoundings. And then we had 598 for our N for the first part. We can fill in our payment amounts except for that last one. So the one on the right here, our payment amount is 1,500. Here's where you want to think, okay, am I getting this payment? That's when it's positive. Or am I giving this payment? Then it's negative, right? In this case, we're making payments. These payments would be negative, right? But here we're getting these payments, so then they're positive. Okay. Working through on the right-hand side here, we know that all these payments are at the end of the payment period. So we can use the end. For the straight compound interest, we'll use the end. I actually don't think it matters. It should give you the same result regardless because there's no payments, so it doesn't care. But we'll just use the end. The only one that's different is the first one where we're making payments because those are at the beginning. Going back here, once we've used up all our money that we have saved, right? Taking payments, taking payments, taking payments, our future value has to be 0. And so our future value here is 0. Now that there's only one missing, we can compute the present value and see what we get. Because what this is going to be present value 1. So then, let's do it. So 300 for N, 8.25 for the interest per year. We're coming back to solve for the present value, 1,500 positive for the payment, 0 for the future value, and 12 payments per year and 4 compoundings per year. Making sure I'm in the end mode, which I am, I have to compute the present value, and I get a present value of negative 191, 154.2953. So just a little summary here. Present value 1 in money is going to be 191, 154, and rounding to 2 decimal places, 30. I'll put a little star here to show that that's the one I'm calculating. This is where our timeline / map, our roadmap comes in handy, right? Because the future value is the same as the present value from the first part. And so this value goes into the future value here. 191, 154, 30. And we're trying to calculate the present value. So this is future value 2, this is present value 3. So now, and for this one, right, for compound interest, it doesn't really matter which one is positive or negative. All it needs is that the present value is the opposite sign of the future value, right? So one has to be negative, one has to be positive, but it really doesn't matter in this case. So 28 for N, I'll re-input the interest per year, just because 0 for our payments, 191, 154.3 for our future value. Our compound or payments per year is 4, compoundings per year 4. Still in end mode, I'm going to compute the future value. Negative 107,927.0766. And so present value 3 is 107, 927.08. So now that value is going to be the future value of our payments that we're making in the first kind of phase, right? And so we have to save that amount. So this is going to be our future value 4. We're trying to solve our payments. We're starting with no money, right? We're saying, okay, we start saving today and we're making these payments. So we have nothing in the bank. So our present value has to be 0. And so our future value here is going to be, just so we get it right, our future value due, if we're making payments, those payments are going to be negative, which means our future value should be positive, right? In theory, we get that money and then we put it back in and it sits there and earns some interest, and then we take it out and then we put it in and we buy this annuity that that gives us $1,500 a month. And so this future value should be positive $107,927.08. So now we can solve for our payment, which is going to be, so N is 598, 0 for our present value, 107,927.08 for our future value, 26 payments per year, 4 compoundings per year, and changing our mode to beginning mode. We can compute PMT, and I get negative 61.07248,259. So then our payment must be $61.07. We did it. Like I said, probably the hardest question on the final, right? And I'd say it was the hardest question on test 3 as well, right? Because it's big, it's long, right? But as long as you kind of keep track of everything that's going on, then it's okay. Right? Any questions about that one? You got it. Okay. So here's that deferred annuity, right, where we have some money, we let it sit until we can get some payments, some regular payments. So Ernie currently has $40,000 in his RRSP. He will let it collect interest at a rate of 3% compounded monthly. He will retire when he has enough money to purchase an annuity that pays $1,500 at the beginning of each month for 20 years, while money earns 6% compounded weekly. How long will Ernie need to wait until he can retire? Right, so he needs to wait until this $40,000 has grown big enough to handle the $1,500 payments. So let's draw our timeline first. So we'll start today, where Ernie has $40,000. He's going to retire at some unknown time point. That's what we're trying to solve for. And then we know that he has to have payments that last for 20 years. He wants monthly payments for 20 years. So 12 times 20 is 240 months of payments. So 239, 1 month, 2 months. I guess I should put a month on there. ... He wants $1,500 at the beginning of each month, right? So we have to shift all these payments to start at the beginning. So the last one is that 239 months. All of these payments will be worth some present value due. Right? And that's when the 40,000 has grown to that present value due, that's when he can retire. Right? And so this 40,000 has to grow to some future value, which has to be equal to that present value due. And we're trying to solve for N here. We've got different interest rates for these sections, right? And so for the first part, it's going to have a rate of 0.03 compounding monthly. And for this section, we've got a rate, R1, of 0.06 compounding weekly, so 52. And here we also have payments per year, which are monthly. Because the payments per year are not the same as the compoundings per year, right? We're going to have to find I2, or if you use your calculator, then you don't have to worry about it. So that's nice. So, all right. First, find the present value due. You can do it on your calculator, you can do it by hand. I'll use my calculator just because it's quicker. And so, N interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. For this first part, right, we had a rate of 6% and 240 payments, right, so N is 240. Our present value, that's the one we're trying to solve for, and it's due, so it's at the beginning. We said we had 12 payments per year and 52 compoundings per year. Our future value, once we've taken out all these payments, the future value of our initial investment should be 0. And our payments are going to be 1,500. We're getting those payments, right? So we'll make them positive. So now we can solve for our present value, 240 for N, 6 for the interest per year. Present value we're trying to solve for, 1,500 for our payment, 0 for our future value, 12 payments per year, 52 compoundings per year. I'm in beginning mode still, so I can compute present value, and I get negative 210, 224.4794. So present value due is $210,224.48. So we have to figure out how long does it take 40,000 to grow to 210,000. And the rate here is 3% compounded monthly. And so now find N. So we need N interest per year, present value payment, future value payments per year, compoundings per year, and beginning or end. we're trying to find N. We've got an interest per year of 3%. The present value is, sorry, 40,000. And because this is just going to be normal, just straight compound interest, it doesn't matter which one's positive, which one's negative, as long as one is positive and one is negative of your future value and your present value, right? And so in theory, right, I would give 40,000 to the bank, and then it would sit there, and then I would get the future value, right? So I'll make this 40,000 negative, but again, it doesn't actually matter. There's no payment amount. Our future value has to be the 210,224.48. We don't have any payments per year, so we have to know our compoundings per year. It's compounded monthly, and so our payments per year are going to be the same, 12. And we'll change it to the end mode. So now we can find our N. 3 interest per year, 40,000 negative for a present value, 0 for a payment, 210,224.48 future value, 12 payments per year, 12 compoundings per year, end mode, compute N. I get 664.54788862. What's the rule for N? You have to always round up to the nearest whole value, right? Regardless of the decimal, you're always going to round up. So we would need N equal to 665 compoundings. Remember, N is time times the frequency. Compoundings, so to undo the 665 compoundings to find time, right, we have to use the compounding frequency, and so 665 is time, which we're trying to find, times the compounding frequency of monthly. So 665 divided by 12, so time is going to be 55.416 repeating years. Or time is 55.42 years. So we have to wait 55.42 years, so almost 55 and a half years until we can retire. It's pretty good. It assumes we already have 40,000 to invest, but not bad. Any questions about that one? No. So again, really similar to what you had on test 3. Last question is going to be that mortgage question, right? And so once you get the hang of these mortgages, they're pretty easy, pretty fun. Right? And so let's see here. Same setup as before, right? Part A, calculate the payment amount. Part B, fill in this table. Part C, how much are you going to have to pay in interest? So copy this. You could calculate it by hand. I would just use your calculator, right? And so we've got N, oops. Sure, N interest per year, present value, payment, future value, payments per year, compoundings per year, and beginning or end. So you purchase a $500,000 home in Kelowna. You're going to make a 10% down payment. Okay. So the present value is going to be 500,000 minus 500,000 times 0.1. Right. Or if you wanted to do 500,000 times 0.9, that works too. So our present value that we're trying to pay off is 450,000. So we can put that in. So 450,000. You're going to repay the remainder of the mortgage at a rate of 3.9% compounded quarterly. Calculate your end of the month. So it's at the end, and your payment frequency is monthly. So end of the month payment. If your amortization period is 25 years, so 25 times 12 makes 300 payments. We're trying to figure out what our payment amount is. Once we've paid off our loan, right, our future value has to be 0. So now we're ready to figure this out. So 300, the interest per year, 3.9, 450,000, which if you want to think about it, it's going to be a positive, right? Because you get 450,000 as a loan, and then you decide to spend it on the house. But between you and the bank, you got this money. So that's the present value. 0 for the future value. 12 payments per year and 4 compoundings per year. Make sure you're in the end mode. Compute PMT. I get negative 2,347.375904. So PMT in money is 2,347.38. So now we know our payment amount. I know I'm going to have to calculate I2, right? Because my payment frequency and my compounding frequency are not the same. And so I'll also find I2. I guess I'll start with I1. I1 is 0.039 divided by compounded quarterly 4. 0.039 divided by 4 is 0.00975. I2, now find I2, is 1 plus I1 to the power of F1 over F2 minus 1. Plus 1 to the power of, so 1 plus 0.00975 to the power of F1, which was 4 compoundings per year to 12 payments per year minus 1. To the power of 4 divided by 12 minus 1, 0.003239494, which I will store in 1. I'll also store it in 0 because sometimes I'm too quick to store stuff and I overwrite it. So I'll keep a backup. Okay. So now we have everything that we need to do part B, where we're going to construct a partial amortization table. Make it as big as I can. So I want the first, the second payments, and then the 250th and the 251st payments and the final two payments. Remember, we have to have row 0, right? The 0th payment. And then I'm told to do 1 and 2, and then a little space. And then I want the 250th payment, which means I also need the 249th future value, right? So that means I need to do 249, and then I can do 250 and 251, ... And then I know I have 300 payments, right? Because my N is 300, and then 299. And to find 299, I need the future value at 298. All right. Our payment amount, well, for row 0, we've got nothing, nothing, nothing. The first thing that happens is the balance, right? And that's just the original balance that we're trying to pay off, 450,000. We've got our payment amount already figured out, 2347.38, and that's going to be the same for all of these. 2347.38. Except for the last payment, because that's the one where we have to make sure, okay, everything's paid off and we've paid off our interest, right? And so it's going to be a little bit different. Okay. Our interest is the previous balance times I2. And so we take I2 times 450,000 and rounding to 2 decimal places, 1,457.77. That's how much of our payment has to go towards paying off our interest. And so what we've got left is 2347.38, which might be easier if you store that somewhere, but I always forget where I stored it, so I'm not going to. Minus 1,457.77. Oops, wrong line. The principal that I'm paying off is 889.61. So what I've got owing is 450,000 minus the principal, which my new balance is now 449,110.39. That's the amount I have to pay interest on the next line. So times I2, 1,454.89, 2347.38 minus 1,454.89. Now my principal is 892.49, 449,110.39 minus 892.49, 448,200, 217, oh, come on, 90. Then we've got a break. Now we go to 249, right? Because what we're going to have to do here is we're going to have to find the future value after payment 249, right? Because that's the balance. And so we're not going to know these two, and that's fine. So here, you don't have to show your work for finding these future values. As long as you have the right value, that's fine. So I'm just going to use my calculator and interest per year. I'll write them across. Present value, payment amount, future value, payments per year, compoundings per year, and beginning or end. The end we're going to have to change to 249, right? That's where we want to know the future value at. So 249. The interest per year is the same, 3.9. The present value is still 450,000. Our payment amount is now 2347.38. Here's a really important part. It has to be negative, right? Because otherwise we're just pretending that we're going to keep borrowing 2,300 every month, and what we would owe would be even larger, right? And so you want to make sure that you've got a negative so you're paying off that loan. The future value is the one we're trying to solve for, and we've still got 12 payments per year and 4 compoundings per year, and we're still at the end. So the only new things here is your N. We added the payment amount. Everything else is the same from before, right? So in terms of updating what's on your calculator, you only have to change your N and your payment amount, and then you can just figure out what the future value is. So we've got 249 for N, and then 2347.38 negative for your payment, and then we can compute the future value. I get negative 110, 184.0044. So what I have to put in the box here is 110,184.00. Now we start over, right? Now we're back to the same scenario that we had for those first 2 payments. We have the first balance, so 110,184.00 times I2. Now we're paying 356.94 in interest, 2347.38 minus 356.94. 1990.44. 110,184 minus that guy. Get 108,193.56, which we multiply by I2. For the next line of interest, 350.49. Did I do that? Is it 49? I've got 50 cents on here, so let me see here. 108, 193.56 times I2. No, I only got 49 cents. Very interesting. Sloppy rounding. 2347.38 minus 350.49. 1996.89. 108, 193.56 minus that guy. 106,196.67. Dot. Same thing here. We have to find the future value at the 298th payment. The only thing that changes, right, is your N, and then you're going to recalculate your future value. Right, so nothing changes now except for your N. Sure. N, interest per year, present value, payment amount, future value that we're trying to solve for, payments per year, compoundings per year, beginning or end. And like I said, you don't have to show this work at all. It's not for marks. I'm just showing you so that you know where it came from. Okay. So N now is going to be 298, and that's going to be the only new thing. Everything else stays the same, 390 or 3.9, 450,000. Negative 2, 3, 4, 7, 38. Calculating our future value, 12 and 4 and end. So only changing my N to 298. Oops. Not sure what happened there, 298 N. And then compute my future value. Yeah. I get a future value of 4,669.986528. So to 2 decimal places, I get 4,669.99. It's on sale. Home stretch here. Calculate the interest, right? So 4,669.99 times I2 is $15.13. 2347.38 minus 1513. Now a whopping $2,332.25 is paying off that principal. So 4,669.99 minus that previous. Now all I owe is $2,337.74. The last row is a special case, right? Because we have to have a zero balance, otherwise we didn't do it right and the bank won't like that, right? So we have to have a zero balance, which means we have to pay off the $2337.74 as our principal, right? And so we have to pay this amount, $2337.74, right? We have to pay off the entire balance. We also have to pay interest on that, right? So times I2, 757 in interest. And then our final payment is going to be those two, the principal and the interest added up. So 757 plus 2337.74. 2345.31. Last thing we're going to do is figure out, okay, what was the total amount of interest paid on the mortgage? Total interest is going to be the total paid minus the 450,000, right? The original loan amount. Everything beyond 450,000 is interest. And so the total paid, we made 299 payments of 2347.38, right? Plus that last payment of 2345.31. So we made 299 payments of 2,347.38 plus our last payment of 2345.31, and then minus the loan amount. So we've got 299 times 38 plus 23, 45, 31 is 704,211.93 minus 450,000. $254,211.93. It's the total interest paid. Yikes. There. Look at how much you guys know. It's a lot, right? But I think you'll have it all under control for the final. And I do want to say that although it was an evening class and kind of boring, you guys are a really fun group. So it's been a pleasure. But now we're all done. Finishing early too. How's that? If you do have any questions, then just let me know. But otherwise, I'll see you at the final. Oh, and remember there's these blank test 3s if you want them for practice. And the sign-up sheet for the review sessions if you wanted to go. All right. See you later.